Hey there, Mazach, and welcome back to day 95 of me doing the NeetCode 50 challenge. So today we're doing another LeetCode Medium 1D dynamic programming problem, and without further ado, let's get straight into it. Okay, today we get LeetCode Medium problem number 5, longest palindromic substring. Seems like we've solved this problem before. Given a string S, return the longest palindromic substring in S. For example, here BABAD, BAB, ABA is also a valid answer, right? Here CC, okay, BB, okay. Okay, so if this is DP, we have several options, right? The most intuitive thing is to essentially do one-dimensional dynamic programming based off the index of the characters in string S, right? Then what do we want? Do we want like, so usually, okay, so if anything, what Eric Domain usually says is like, you either do prefixes, so it's like, S from 0 to an index I, or, you do as suffixes from S to I to onwards, or if you need both, never try to fit it to something like this, right? Make it substrings, right? So it's like, S from I to J, right? In this case, if this is a 1D dynamic programming problem, we probably can't just do a string ij, right? What are the constraints for this problem? Okay, so it's 1,000, so it's 10 cubed, so something like n squared is definitely valid, right? So if anything, we could do, right, yeah, one thing we could do is essentially 2D dynamic programming, right? If anything, if you're going to do, for 1D dynamic programming though, one thing we could do though is not essentially think in terms of prefixes or suffixes or substrings. We can just be like, essentially find the longest palindromic substring that's centered at an index I, right? Or if like, I is at the center, or like I and I plus 1, right? To essentially have the two characters and so on. Maybe that's the 1D DP type of way, right? Here we'll do DP. First of all, we'll do also, sorry, my I just came rock climbing, so my fingers, at least the tip of my fingers kind of hurt a little bit. But I'll try to, type through the pain. But yeah, so if I type a little slowly, that is why. So self, comma I, a J, right? So here one thing we'll definitely need is self.s is equal to S. And here we'll return self.dp. Right. The only problem with this is that I'll need the max one, right? Or here we can do for I in range, length of S, or J in range, return max of self.dp of I comma J, for I in range, length of S, for J in range from I plus 1, length of S. Or we can also do from I onwards, right? That's also possible. And here we'll say, here we'll say if I is greater or equal to J, return whether I is equal to J, right? Here we can put a cache decorator, or, well, okay, since we're in the DP topic, I'll just always use self.memo instead of a cache decorator. If I comma J in self.memo, then returns self.memo of I comma J, right? Here it's like, okay, if I is greater or equal to J, then it better be the case that I is equal to J, right? And like, obviously it's a length 1 palindrome. Well, okay, is the length of the string S always 1? Yeah, so if anything, we'll do length of the string. Here we'll do I plus 1 onwards, and by default, we'll say is equal to 1, right? There we go. Yeah, otherwise, if self.s of I doesn't equal to self.s of J, return false. Otherwise, return self.memo. Return a res is equal to self.dp from I plus 1, J minus 1. Self.memo of I comma J is equal to res, return res, right? Here, if anything, we can do self.memo of this is equal to false, return false, right? Well, really not. It's just like it's an easy O1 check. Yep, sure. So all of this can be parenthesized. That's not a problem in the world. Wrong answer. Oh, it just returns true or not. Return 0. Equals res plus 2 if. There we go. Oh, here I need to return the actual palindromic substring. Okay. Here we'll do for I in range best I, best J. Longest equals 0. For I in range, length of S. For J in range, here we'll do 0 and 0, and here we'll do a length of 1. J in range, I plus 1 all the way up to the length of S. We'll do if self.dp of I comma j is greater than longest, and we'll say longest is equal to self.dp of comma j. Best of I is equal to I. Best of j is equal to j. Return S from best I to best j plus 1. Right, okay, so this works, and is this fast enough, right? Might not be fast enough. Okay, it is. Okay, it's fast enough, but clearly there's a much better way of solving this problem. Okay, so yeah, and plus, if anything, this is super slow work, and this is 2 DDP, right? And the number of subproblems here is n squared, right? Because it's up to n indices for I and n indices for j, or like, you know, even though it's like, you know, j must be greater than I, it's still like O of n squared total subproblems. The recursive work per subproblem is indeed O of 1, so that's fine. And then here I do O of n squared work again. DP in total will be O of n squared work. But yeah. Obviously, this is a pretty slow solution, and it's probably not in spirit of what was expected for this solution, just because it's like obviously some people have much faster runtimes, and also this is expected to be a 1D dynamic programming problem. So for now, what we will try to do is essentially try to solve this as a 1D dynamic programming problem. Then I'm taking 10 seconds at this point when I do that little change right there. So yeah, this is very bad. Yeah, okay. So there's probably a better way, right? My intuition would tell me, so here we'll restart the problem. Here we'll have a def dp, right? And obviously, it's probably good to have an index I, right? Here, we'll say dp of I, longest palindromic substring. Centered at I, centered I comma I plus 1, right? So that's my idea. Or we could do dp, like, we could do dp odd and dp even, right? So dp for even length palindstroms and dp for odd length palindstroms, right? I can split it up into 2, or I can do it this way, right? dp odd length, def dp even. So come on j, and then it's like assert that I plus 1 is equal to j, right? Instead of this, we'll just do def dp even, comma I, right? And then instead of this, dp self comma I, we'll just do this. dp odd of I means longest palindromic substring centered I. dp even I returns longest palindromic substring centered at I plus 1. Or do I even need two functions for this? That's what I'm asking myself, right? The point is that like I have it as my left center, right? So if anything, yeah, I can probably have it inside of one dp function, right? So, but the point is that like, you know, I'm just gonna keep doing work, right? Like I don't understand why this will be so much better, if anything. Because how am I gonna use it? If I do it based on centerings, how am I gonna use it between, like how am I gonna call dp nestedly, right? Unless I'm doing it in 2D dp. I don't like this. Am I going down the wrong route? This is 1D dp, right? That's interesting. So the hard part of dp is always coming up with the way to do the subproblems, right? We are indeed allowed n squared time, right? I like doing it in 2D just because it's like you can nicely come down to the subproblem, right? Here, prefixes and suffixes doesn't really make much sense when we're trying to deal with substrings, right? Right, my guess would be like, if anything, what I would do is a 2D dp. Yeah, what I would do is a 2D dp, def dp, self comma I comma j, and just returns a boolean of whether it's a palindromic string or not, right? That's the point. I comma j in self.memo turns self.memo of I comma j, right? That's like I is equal to j, turn I is equal to j. And then self.s of I doesn't equal self.s of j. Return false. If res is equal to self.dp of I plus 1, j minus 1, self.memo of j is equal to res, return res. Right, and then it's like y in range, like the ves, j in range, like the ves, longest is equal to 1. If j minus plus 1 greater than longest and self.dp of I comma j, best j, best I, best j, I comma j, j minus I plus 1. Return s from best I all the way up to best j plus 1. Right, that would be my idea essentially. It's equal to 0, 0 at the beginning. Doesn't really matter. Right, but the point is that something like this should work. Yeah. Self.memo is equal to this. Self.s, self.memo, s comma this. Really, this is not correct. I really now. Yeah. Wait, why doesn't this work? No, but that'll get encapsulated, right? Right? If they're equal, then it'll be like, yeah, I becomes greater than j. Oh, no. Yeah, that's why. What I want to do is essentially odd length palindrome, base case, odd length palindrome, base case, even length palindrome, base case, not a palindrome, is greater than j, true and false. Really? No. What I want is S of I set of S of j. Right, there we go. And now I submit something like this. This is essentially how I would solve it, right? Because in terms of thinking of it in a DP way, this is how I think of it, like in a 2D way, right? But yeah, it's very, very slow. Maybe here I can skip out on a bunch of work. J minus I plus 1. If I want to be greater than longest, right, I need J to be greater, I need J to be greater than longest plus I minus 1. So it needs to be greater or equal to this plus 1. So longest plus I. And longest plus I does this work? Right. Does this make me go faster? Yeah, but not quite enough, right? So people are clearly doing this in an O of N type of way that is very, very nice and efficient. What could they be doing, right? Is it really centered? Because like, okay, this is perfect, yeah, for 2D dynamic programming, right? But 1D, because making it longest palindromic substring that ends at or starts at index I is kind of nonsensical. Right, because you kind of have to keep going and so on. It just ends up being O of N squared work anyways, right? It's just like if you make it based off the center, then it's just, I don't know how it relates to other DP subproblems, right? It's one of those things where it's like, how Eric Domain says, where it's like, if the problem is really based off substrings, do not start trying to do prefixes or suffixes, right? Which is why I'm like drawn not to do those. Yeah, I'm drawn to the idea of doing it at the center, but if you do it at the center, how do you relate the subproblems to others? How do you do this in 1D? Clearly, right? Like they give us enough time to make it an n squared algorithm. Is there a way to actually do this in linear time? I mean, we can try based off doing it off of dp 2D. dp solution. I'll try def dp. Because the worst case is like, what if you have the same letter over and over and over? You end up doing n squared work anyways, right? It's just for the spirit of trying to get it into 1D DP, right? Just that a lot of times I guess you won't have palindromes, so it's just like you'll short circuit very early. So maybe that's why, even though the worst case time complexity will still be n squared, it's just like you know, if you have 1,000 A's, there's not much you can do, right? So yeah, I guess maybe we do it that way. But then it's just not really, it's fake DP. It's not really DP, like at all, because you're not recursively calling based off other subproblems, right? It doesn't feel like DP at all if I do it this way. But then if I do it as a prefix, it just does not make sense. This is tricky. I wonder how I solved this before. Is there any hints? Yeah, there are any hints if we need them. Delta dp, yeah. It's just like, yeah, if I do it based off centering it at an index I, how am I going to make it subproblem based, right? I'm not going to be calling... Like, at that point, it's like, it might as well not even be dp. It might as well just, like, I just do a for loop, right? Like, you know, for every single center index I, it's just, yeah. It's not dp is what I'm trying to say. Like this is, what about, yeah, so palindromic substrings. This is another one, right? Where it's like, you know, I could do something like this, right? Where it's like I make it 2D DP, right? And it's just like I return true or not if ij is palindrome. And like this is naturally dynamic programming, right? Yeah, it's just not like it's a substrings problem. It's just so natural to do this in 2D. If I center, like I'm gonna end up having an n squared algorithm, right? Am I just writing 1D for the sake of writing 1D? Like, okay, I guess we can try, but if this doesn't work, like, you know, I'm kind of out of ideas. Or not that it doesn't work, but like if it doesn't make it like, you know, efficient so that we're like close with a pack over here, I don't know what to do. Okay. Here we'll say, well, assert 0 less than or equal set.s equals s. Like, I don't need a memo, is what I'm saying. Right? Like, here it's just like, you know, for center index in range of S, case 1, odd length palindrome, var is equal to center index, lambda inbounds equals lambda 0 less than or equal to I less than length of s, right? Here we'll even say n is equal to length of s. Here, oh gosh, we'll say n. Here we'll say n. L and inbounds R and S of L equals S of R. L plus or equal to 1. L minus R plus or equal to 1. Should execute post one time. Right? Case 2, even length. Or S of R. Continue. Otherwise, we can try it. And here we'll say the same thing. Right? Well, inbounds like this, yeah, keep making it bigger. Yep. And then here, return s from I to j plus 1, right? That's kind of my idea here. There. If anything, we should do it this way, right? Well, inbounds L minus 1, and inbounds R plus 1, and S of L minus 1 is S of R plus 1, then there we go. And there we go. Really, this does not work, eh? BB. Okay, I guess that works. Okay, is this faster? Oh, okay, I guess I'm in that center. Okay, I'm much closer to that standard deviation here. Okay, so maybe that's the way? Okay, so I guess it's, yeah, it's 1D where you center on the based off where you can center the palindrome, but it's not really DP. It's brute force kind of. It's just you get lucky with the sub problems, right? One D fake DP solution. Self dot DP 1D S. We'll do def DP 1D. Oh yeah, return this. And yeah. I could also do longest is equal to 1, right? Yeah. Here we can do a minus 1. And then this is this. Right? And then this should still work. Yeah. I mean, I guess we're in... Are we in that standard deviation? I don't know. It's just, I don't know. It's just, I don't know how to relate it in terms of 1D DP problems, right? Here, I guess what I can do is, while L minus 1 is greater or equal to 0, so L is greater or equal to 1. While L greater or equal to 1. It's like, well, L minus 1 is greater or equal to 0, right? You don't want it to be negative. And R plus 1 less than N. Right, so here we can do L greater or equal to 1. R less than N minus 1. Right, and then we don't need the inbounds function. Maybe the O of 1 stuff there makes stuff go away. Oh, wow. Okay, now we're at 259 ms. Beats 78.49%. Okay, so it seems like that's the expected solution. It's just that, like, in terms of worst case complexity, it's just not gonna help. Where it's like, if all the strings are A's, then it's like you're dead, right? But it's like, yeah, here it's like at least I don't do any memorization and so on. But here, like, I'm not necessarily doing dynamic programming, right? Which is why I don't like this problem, where it's like I solve this problem in just like I guess there's the idea of DP where it's like, you solve the problem for every single index I, where you center off index I and then return the biggest one, right? I guess it's 1D DP in that way, but yeah, I don't like this problem too much, just because it's like, yeah. I guess it's like you can argue that it is DP, but I kind of don't like the argument. But Nevertheless, so as always in all my videos, I do a quick recap if I was able to solve the problem. So for this one, the problem is very, very simple. It's problem number 5, actually. Longest palindromic substring. Simple to understand, sorry. Given a string S, return the longest palindromic substring in S. If you're not familiar with a palindrome, it's essentially a word that can be read the same way forward as it can be read backwards, right? So for example, race car, my favorite palindrome, can be read the same way forwards, race car, as backwards, race car, right? And the nice property about palindromes is essentially it's like it has a center, right? For example, in this case, it has E, and the point is that like here it's like, you know, you have to add the same letter to the front, to the left and the right, right? So here you'd have C's like this, here you'd have A's like this, right? And here you'd have R's like this, right? And so that's why it's a palindrome. It had a center of the letter E, and then it's like, you know, the two letters adjacent to it are the same, which are these C's, adjacent to it are like these A's, and the R's are like, you know what I mean? That's essentially a palindrome. Or it can have an empty center, right? So it's like if I have a beeb, right? It's like, you know, the center here was this empty string over here, right? And then it's like, you know, to the left and right are these E's, the left and right are these B's, and so on, so it's a palindrome, right? Or essentially another way to think about it is like, you know, the center is these two E's right next to each other, right? So, because the point is you can have even length palindromes as well as have odd length palindromes, right? And the way that I solve this problem is the very first way that I did it is with 2D dynamic programming, just because it's much more intuitive to me, right? 2D dynamic programming, the way that I did it is essentially it's like, okay, we're going to return true if and only if a substring from I to j is a palindrome of S, right? So first of all, I do the classic, like, you know, if ij in self.memo, return self.memo of ij. If I is equal to j, okay, well, this could be a return true, lol. Yeah, so first of all, if I is equal to j, it's automatically a palindrome, right? If I is equal to j, it's just one character, right? So if I just have one character like a can be read the same way forwards as backwards, so it is automatically a palindrome, right? Otherwise, if, you know, I plus 1 is equal to j, that means I have two letters, right? So like something like AB. This is a palindrome if and only if the two letters are equal to themselves, right? AB is not the same as BA, but AA is the same thing as AA read backwards, right? So if I plus 1 is equal to j, then I only return true if the characters are the same, right? If self.s of I is equal to self.s of j. If I is greater than j, then it's just like, you know, a base case of like, you know, false, right? So it's like, you know, I surpassed, so then it cannot be a palindrome. Otherwise, it's like, okay, the way that I'm going to do this is like, okay, I'm essentially going to have a palindrome from I to j, right? So essentially I can think of it as like, have the two characters on the ends be I and j, make sure that they're the same, and if they're the same, then essentially recursively call from I plus 1 and j minus 1, right? So the point is if I have something like race car, right? The very first thing I'm going to check is like, okay, is the end equal to the beginning, right? And if not, then I'm immediately going to return false, right? For example, if I have race cab, then base car is not going to be the same thing as race cab, right? This B and this R don't match, so it cannot be a palindrome. So if they're not equal, then I'm immediately going to return false, right? Otherwise, if they are equal, then it's like, okay, great. I can essentially kind of get rid of those ends and then check if the rest of the string is a palindrome, right? So what I'm going to do is be like res is equal to self.dp from I plus 1 and j minus 1, right? If this was my I over here, and this was my j, I'm essentially going to decrement my j as well as push my I forward, right? And that's the point. And then from here, I'm going to check, okay, these A's are the same. So I'm going to move my index I onwards over here. My index j, I'm going to delete it and move it over here. And then it's like, okay, these characters C's are the same, right? So I'm going to move my I over 1, and then it's like this j is going to move over 1, so the j and the I are the same. And remember, when I equals j, we return true, right? So in the case of race car, we would return true, right? And that's why I like the 2D dynamic programming problem, because essentially you end up recalling the DP function, right? It's like if you want to know if it's a palindrome from I to j, essentially you have your little base cases. So if I equals j, obviously it's true. If I plus 1 is equal to j, it's only true if the character is the same. If I is greater than j, obviously not. And then it's like, okay, otherwise it's like make sure that I and j are the same. If they're not, automatically return false. Otherwise, if they are the same, it's like, okay, continue problem from I plus 1 and j minus 1. So it works very, very nicely in that way. And then it's like, okay, for every single, you know, for every single pair I and j, essentially it's like, you know, call dp of ij, and then it's like, oh, if it returns true, that means it's a palindrome. So if it's the longest palindrome we've seen so far, update the best I and best j that you've seen so far to be those I and j's, right? And at the very end, just return the best palindrome, right? And so that's essentially how I did it in terms of 2D. Now, in terms of the 1D dynamic programming, I actually didn't like this problem too much because it's kind of like as I wrote it here, it's like, you know, fake DP. It's DP in the sense, so the way that I did this in one dimensional is essentially what I said is like, the DP part comes from the fact that essentially I'm not going to do, so Eric Dermain, the guy that taught me DP really from MIT with his DP videos, always says that like when you're going to do dynamic programming, if you are dealing with substrings, never ever try to form the problem in terms of suffixes or prefixes, right? If you try to do prefixes and realize you need suffixes, or you use suffixes and you realize you need prefixes, always do substrings, right? With like your longest palindromic substring or number of palindromic substrings are perfectly fine, which is usually 2D DP with like an I and a J, right? Here the problem is that, like, we're given that this is a 1D dynamic programming problem, so we need to find a way to do it in 1D. Obviously, because we're dealing with substrings, something like prefixes or suffixes isn't gonna cut it. So I was trying to think of, like, what way could we do this in 1D DP without using prefixes or suffixes, because, always listen to Eric Dermain. And the only thing I could think about is essentially, it's like, if you have an index I, make that the center of your palindrome, right? And essentially try to expand from that as much as you can, right? So like from an index I, it's like, I might have an A, and like look at index I minus 1 and I plus 1, right? And if these are both the same letter, then it's like, okay, that's a palindrome. And so keep expanding from that index I, which is your center, and essentially go on until you find the longest possible palindrome from that centered index I, right? So the point is essentially, it's like, you do DP of index I, where DP of I would essentially be like, longest palindromic substring centered at I, or centered at I and I plus 1 for the case of an even length palindrome, and then like return the maximal one, right? Out of every single index I as a center, return the one that was able to give you the largest palindrome, right? So I guess it's technically DP in that sense. It's just that I didn't like it because you couldn't really like, usually with like DP, it's like, you recursively call upon the same subproblems and so on. In this case, you really didn't, right? You didn't have like, a DP table. You didn't use a memoization table. You didn't do anything like that of the sort, right? So it's just like, it was really more of a brute force problem where it's like, grab every single index inside of S as a possible central index of a palindrome and essentially try to expand from there and so on. So basically I'm brute forcing, I'm never caching results and so on. So that's why to me it doesn't feel like a natural DP problem, unless there's a way to do this in 1D DP and it's better and so on. But like since here it's like, I resubmitted and I got a reasonably efficient solution. Here we can resubmit again just because I think we made a few changes. But like this is the thing, right? So we're at 78.49% and so on. So we have a relatively probably like, super fast solution here. So it's like, it's like, I don't know if there's like, a better way to do this problem and so on. So it's like, but it feels very, very brute forcey without the caching part. So it's like, I have a hard, troubling time to call this DP, right? But otherwise, in terms of how I did it, it's like, okay, for every single index inside of our string S, here we'll ignore the last index because from the last index, you can't expand from the right. So if anything, we can make this, from index 1 comma all the way up to n minus 1. And this would make things a little bit we hide, yeah, this is not going to be the case. Because if we're going to do center at index I and I plus 1, there might be a length 2 palindrome. Yeah. So we can't do this. I literally figured, I literally thought of that as soon as I submitted. So that's my bad and so on. But yeah, so in terms of how I did this, otherwise, we don't have to consider the last ones because essentially for every single center index, you can consider them all if you really want to. It's just I realized that I didn't need to. It's like, okay, the longest palindromic substring that I'm going to say that I have so far is 1, right? Because I can always pick, any index and essentially make my I and J that index and be like, okay, any string of length 1 is a palindrome itself. So just pick any string of length 1, right? I just pick like, from 0 to index 0, and that's a length 1 substring of S that has to be a palindrome, right? Because the length of S is at least 1. And so otherwise, essentially what I'm going to say is like, okay, for every single central index inside of the range n minus 1, where n is the length of S, we're essentially going to say, okay, center index is going to be the index that I essentially centralize my palindrome. If it's an odd length palindrome, then essentially that's going to be the center. So I say my L and R is initially just the central index. Otherwise, for an even length palindrome, I'm going to make my L the center index and then my R the center index plus 1, right? So essentially it's like 2 characters to essentially build a palindrome from, but it's the very same concept, right? For an odd length palindrome, I make these the same, and then I'm just going to like, okay, while, subtracting, so I want to subtract L by 1 and R by, and add 1 to R, right? Because I want to keep making the palindrome bigger as long as I still have a palindrome, right? Here I'm starting off with the palindrome because I'm starting with a length 1 string, which is guaranteed to be a palindrome, right? And so here it's like, okay, while L is greater than or equal to 1, this is the same thing as while L minus 1 is greater than or equal to 0, right? Because I'm about to subtract 1 from L. So I want to make sure that I can't subtract from L. I want to make sure that I can add 1 to R, right? And that L and R would still be in bounds. And if, S of L minus 1 and S of R plus 1 are the same character, then I know that if I subtract L and add R, I'll still have a palindrome. So I'll do exactly that because now I have a bigger string to play with that's centered at that center index, right? And then I say, okay, if this is, if the current LNR that I have, if the length of that is bigger than the longest palindromic substring that I have so far, then update INJ to be LNR and update the longest palindromic substring that I have to the current substring that I have, right? R minus L plus 1, right? And then I'm going to do the same thing with an even length palindrome, right? Here, since L and R is going to be equal to center index and center index plus 1, it could be that they're not equal to each other right off the bat. So if they're not equal to each other off the bat, I don't have any even length palindromes from here, so I just continue the for loop, right? We didn't have to worry about this here because when I have them as the same index, it's just a length 1 string, which is guaranteed to be a palindrome, right? But otherwise, if they are the same, then it's like do the same work, right? So while subtracting L 1 from L would keep it in bounds, while adding R 1 to R would keep it in bounds, and it is the case that L minus 1 and R plus 1, i.e. if I subtracted 1 and added 1 to each of those respectively, would keep the string a palindrome, then I'll keep expanding by saying L minus equal 1 and R plus equal 1, right? And then I'll check again, if the current substring that I have is greater than the longest palindromic substring that I have, then I'm going to update INJ to be LNR and essentially reinitialize my new longest string, right? And at the very end of the problem, my INJ will essentially be, the coordinates, the indices that lie with one of the longest palindromic substring inside of S. So I'll just return that palindromic substring from I to J inclusive, right? Which is why I do this J plus 1, right? And that's essentially it. And so in terms of how this is DP, I guess it's because you have N subproblems where the subproblem is essentially the longest palindromic centered at an index I. Here I call it my center index, and then essentially return the maximal of all of those ones, right? So I guess it can be called DP in that spirit, but I don't really like calling this a DP algorithm just because it's you have no element of the subproblems being related to each other. It's just you end up doing all these subproblems that are very, very independent and not kind of talking to each other. So I didn't enjoy this dynamic programming problem just as much because it's it doesn't have that relationship. A DP is kind of like a DAG, and here it's oh, you technically have a DAG because you have N nodes that are with no edges, right? So it's a graph with N nodes and no edges is just very, very uninteresting, right? So that's why I found this DP problem kind of uninteresting, just because it's like a DAG that is, I guess, I don't know if N undirected, unconnected nodes is a DAG necessarily because they're not connected, but the point is, you can, with N nodes that don't have any edges between them, you can still topologically order them. It's just that the topological order can be anything, right? I can just shuffle these N indices in any way I want, and I'll still have the problem when I want, right? It's just that's the DP problem, right? You essentially have a DAG with N nodes and no edges between the nodes, right? And so solving a problem with N nodes and no edges as a directed acyclic graph that you must traverse and have results from is just, at least to me, is just very uninteresting. So if anything, this one was kind of a miss for me. But I won't complain. We have a crap load of DP problems left to do. So I'm sure that we'll find some enjoyment out of those. But this one, in my opinion, was a little bit of a miss. Not gonna lie, but oh well, we'll have some fun with some other ones, right? I also had some good ones. I think this one, by the way, I started this problem in class to connect all points because it's just solving it was very, very, very satisfactory, and every other problem inside of the NeetCode 150 so far has been really satisfying to solve. Here I'll just mark the fact that I did this problem over here, but yeah, this one maybe was a bit more of a miss in terms of enjoyment for me. But hey, maybe it's different for you. So hopefully it is different for you. But yeah, for me, I enjoyed this one a little less. But otherwise, that is pretty much it for this video. If you did find it useful and enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.